So here we have the final exam version of that type question we've already seen on the midterms. Now, of course, because the final exam does cover all that other material from the midterms, you could see a final exam question about the types of other things, but go take a look at the videos about the previous practice midterms for practice on that style of question. The one I want to talk about here, the new style, is one that involves structures. And so this example has two different structure types defined, this type XY pair, which just contains members X and Y, and this thing called line segment. And I guess it's based on the contrived idea that a line segment can be represented by 2 points in space, two of these XY pairs. And so the goal is to take this and then later to answer questions about the types of different expressions. So to do that, we're going to need a diagram. So I've cheated a bit. I've already drawn up onto my diagram the structure definition for the first two things, just to save some dead air. And so my first assignment, pair A equals 6, 10. Remember that when we're initializing a structure, if we provide it an initializer in curly brackets, we just assign members in the same order they appear in the structure definition. So the first thing is the 6, and the first member to appear in the definition is X, and so 6 goes into X. And so pair A ends up containing 6 and 10, and pair B ends up containing 17 and 187. And then I create a pointer to an XY pair, so we'll put that there. And it is initialized to be a pointer to pair A. And the key thing to remember, of course, is that if we create a pointer like this, well, the type of this is going to be XY pair star. The type of the name pair A is XY pair, and so the type of an arrow pointing at that would be XY pair star, but also that when I end up storing that pointer, it's a pointer to the entire structure. We're allowed to make pointers to the individual members of the structure, as you know, for example, from assignment 6, but in this case, we have a pointer to the whole structure. And then I create an object of type line segment. And I'm going to cheat a little bit here too. I'm going to just, I've copied one of those before to save a bit of writing. And that's called seg. And it is initialized with a curly bracket initializer to be the value of PT. So the value of PT is this arrow, which is of type XY pair star. And I notice that the very first member of my line segment structure is of type XY pair star. It is start point. And so start point ends up being this arrow. Notice that, and we remember this from October, remember that I can just use the value of this pointer. And what I'm asking is, what is in this box? Don't make an arrow pointing at this. Give me the arrow that's currently stored in this. And then the second member of my line segment is going to be an arrow pointing at pair B. Okay, there we go. And then we've got some more weird stuff happening. So we've got XY pair star star. And that will be called capital Q. And that will contain an arrow pointing at PT. And we can verify that PT has type XY pair star, and so an arrow pointing at it will have type XY pair star star. So that looks good. And then finally we have this variable R. We'll put that over here. And R contains a pointer that points at, an arrow pointing at my line segment from earlier. There we go. Okay, so we have this diagram all drawn up. Now we can begin answering questions about the types of individual expressions. And just like on midterm 2, we could discover that some of these expressions are invalid. So we've got the expression ampersand seg. So create an arrow pointing at my variable seg. Now, generally, I should expect this to be valid. We can generally create arrows to any variable that has a name. Okay, so seg is of type line segment. And that means an arrow pointing at it would be of type line segment star. And actually, I sort of get this one for free because if we look at the variable I created most recently, R, that actually has the value that the question is asking about. It is of type line segment star. So we've got this one. We're easing in. Star Q. So I start at Q and I follow an arrow. Where do I end up? And this one's also pretty easy just because I can just look at my diagram. I start at Q, I follow an arrow. I end up somewhere with type XY pair star. R dot start point. So we have to consider here that if I ever see the dot operator in the context of a typing question like this, the first thing I need to be asking is the thing on the left of the dot, that is the name R, is that a structure of some kind? Not a pointer, a structure in its own right. And so that's the first thing I'm going to check. Okay, well, R is a pointer, so I can't use the dot on a pointer. You could only use the dot if the thing to the left, whatever the operand to the left is a structure, not a pointer to a structure. And so in this case, this would be an error. Star Q arrow X. So this is just like with the dot. If we ever see an arrow, we have to immediately check whether the thing on the left of the arrow, that is the expression star Q, whether that is a pointer to some kind of structure. You can only use the arrow if the thing on the left is a pointer. You cannot use the arrow if the thing on the left is a structure. Okay, so I guess what's star Q would be our first question. Star Q would be this thing, an XY pair star. Which is a pointer. So I could try and use the arrow operator on that. Okay, so the full expression would be start at Q, follow an arrow. Okay, so that's do this stuff. And actually, I could write in that that just takes me to the value of PT. And then from the pointer PT, follow the arrow and get me the member X. So can I do that? Okay, so if I start at Q and follow the arrow, I do indeed get to PT. If I start at PT, I follow the arrow and go looking for a member X inside where I end up. Hey, there it is. It's got the value 6, and it's a float. So this is a valid expression. And it's worth breaking down into those two parts. First, work out what star Q is, and then based on where you end up, decide whether the arrow makes sense, and then finally what happens if you actually follow it. But I was able to do that, and I ended up at a float. Star Q, arrow Y. Okay, so if I start at Q and I follow two arrows, where do I end up? Start at Q, follow an arrow, I end up at my variable pair A. So I could actually write that in. And the problem here is that if I look at what's to the left of the arrow, I'm writing actually pair A, arrow Y. Well, pair A is a structure. It's not a pointer. I can't use the arrow operator unless the thing on the left of the arrow is a pointer of some kind, and so this is an error. It's worth noting that it isn't the star Q that caused me trouble. I was able to start at Q and follow two arrows. It's that once I got there, I can't use the arrow on the result because I'm actually at some kind of a structure. All right, ampersand seg dot x. I already have a suspicion about whether this is going to end up working. Even if I don't know the type of this thing here, there's already something that looks a bit wrong about this. So I'm only allowed to use the dot operator if the thing on the left of the dot is a structure. But based on what I'm doing over here, it's pretty obvious that it's not going to be. I'm using an ampersand, which means it doesn't matter what the type of this thing is, what I end up with will be a pointer. And so I can actually preemptively say, this isn't happening, this is an error. But if we go take a look at it, we can see what we end up with. So if I write ampersand seg, then I get this notional arrow pointing at my, my line segment object seg. And of course, once I've created this arrow, I can't attempt to use the dot operator on it because you can only use the dot when you are actually standing at a structure. So that would be an error. Ampersand pair A dot Y. Okay, actually, this is the same problem. So I know that no matter what pair A actually was, there's no way that ampersand pair A, an arrow pointing at something, is ever going to be a structure in its own right. It could be completely valid to use the arrow here. We'd have to do more checking to determine that, but it is definitely not valid to use the dot. We need the thing on the left to actually be a structure. And so again, this is an error. It's almost an error without even knowing the type of pair A. We can just say the dot would never make any sense there. PT arrow Y. So I start at this value PT, I attempt to follow an arrow and then fetch the member Y. Now I've mentioned before that if you don't like the arrow operator or if tracing the arrow operator bothers you, you're always welcome to sub in a dot and a star for any occurrence of the arrow, which is, in this case, if I write this expansion here, that is identical to this. And so if you ever see an arrow, you're welcome to convert it to this and then solve it that way. But in any case, I'm starting at this variable PT, I'm following one arrow. Wherever I end up, I'm attempting to go in and grab the member Y. So can I do that? Well, there's PT. I follow an arrow, and then I go grab the member Y. There it is. It's a float. And then finally, start at the variable R, attempt to follow an arrow and then grab the member start point, and then from there, follow an arrow and grab the member x. Now, you can write this in terms of dots and stars. I don't know whether it's actually going to be that much easier to read. So I'd end up with something like this. Follow the arrow from R, and then grab me the member called start point. Follow the arrow from that, and we can see now that these nested arrows, these nested stars and dots are probably not making our life any easier. But we could end up with this expansion. And as I've said, you're welcome to do that, although I think it will probably save you time to just learn how to read the arrow operator directly. So I'm going to try and start at R, follow an arrow, and grab the member's start point. Let's see if I can do that. So I start at R, I follow an arrow, and then I grab the member's start point. That worked. When I do that, I have a pointer to pair A. So maybe what I should do is actually just, I could just cross this out, and I could write in, this whole thing ends up being a pointer at pair A. And then I want to follow that pointer and grab the member X. Okay, so if I have a pointer to pair A and I follow the pointer and grab the member X, well, it seems like that should be valid, because if I have a pointer to pair A, then I obviously could follow that arrow. So I've got my arrow pointing at pair A, I follow the arrow and I try and grab the member X, and I'm able to do that, and it is a float. So as I've said, you can expect to see a question like this on the final exam, where you're given some structures, maybe arrays of structures, maybe structures containing arrays or pointers to structures, and then asked to determine the types of various expressions. You should also expect there will be some of those type questions like you saw in midterm 1 and midterm 2, because the final exam does also cover that material, but there is a previous video, the practice material from the other midterms, you could look at for reference on that stuff.